Buonasera, meaning good evening in Italian. Some of you speak a lot better than I do, taking some Italian, but we toss it in there. In today's lesson, 5.7, we're going to be proving figures are special quadrilaterals. So it's really knowing that chart. So you're going to be able to know that chart and then being able to describe if it's going to be a quadrilateral, kite, rhombus, square, whichever one it's going to be. So let's just jump right into it. You're going to give the most descriptive name for the figure below. Sometimes it's a word, sometimes they're in pictures. You're going to have to be able to interpret what it is. And so the first one says a quadrilateral with both pairs of opposite sides parallel. So it's a quadrilateral. Both pairs of opposite sides are parallel. So the best thing you can do is a parallelogram, because that's what it is by definition. Number 2 says a quadrilateral where the diagonals are perpendicular. Well, right off the bat, we know a kite has perpendicular, but then we also know that the rhombus, which is a different part of the family from our family story, has it. So we can't decide one over the other. We can't just be like, oh, I prefer it's a kite over something else. So no, so we're going to have to just say it's a quadrilateral. Number 3, it looks like we have the diagonals. What are the diagonals doing? They're not bisecting each other, but the top two are congruent, the bottom two are. So that is the one that looks more like this. That's what was special about the isosceles trapezoid to give us that answer. Even though they all look like a parallelogram to me, they're not going to change. The next one is that these ones, the diagonals, bisect each other. So the diagonals are being bisected. Okay, so what do we know there? Well, by the definition of a parallelogram, the diagonals are bisected. In 5, the diagonals are bisected, but since these are the same and these are the same, they're all the same, that means to begin with, the lengths of the diagonals were also congruent. So the diagonals were congruent, and they bisected each other, which by our rules is a rectangle. And last, so we have the idea that it's a rectangle, but what else do you have? You have that there's a right angle now when the diagonals bisect each other, so it's the same stuff, but the diagonals are also perpendicular, so that's when we made it into a square instead. So you have to be able to look at the picture and take it apart. And number seven, you're going to have to be tested on this type of question. That'll be like about 10 points each, and it's dealing with slopes that we did in 4.6. A lot of slopes. So we'll call each point a different letter. So A will be at 6. So let's plot it. Over 1, 2, 3, 4, 5, 6, up 1. That's A. B is at 11, 0. So there's 10, 11, 0. C is at 10, over 10, up 5. There's C. And then D is at 5, 6. Okay, we connect our lines. You can't tell what it is by looking at it. But what we do know is we can tell if it's going to be in the parallelogram family by having opposite sides being parallel. So what you're able to do is you're able to find the slopes of all 4 of these. So AB, BC, CD, and AD. So if we do the slope of AB, remembering the slope formula is y2 minus y1 over x2 minus x1. So AB, so we get 0 minus 1 over 11 minus 6, giving me negative 1 over 5. BC, we get 5 minus 0 over 10 minus 11, giving us 5 over 5 minus 0 over 10 minus 11 over negative 1. Okay. We have CD, which giving us 6 minus 5 over 5 minus 10 1 over negative 5. And then we have AD, which is giving us a to the 6 minus 1 over 5 minus 6, giving us 5 over negative. The other two slopes that we're going to have to find for sure every time are going to be the diagonal too. So to continue, we'll get the slope of AC. And between A and C, that's 5 minus 1 over 10 minus 6, giving us 4 over 4, which is 1. And then BD ends up being 6 minus 0 over 5 minus 11, which is 6 over negative 6, which is negative 1. Okay. So what did we learn? Well, we learned that AB is parallel to CD. We also learned that BC is parallel to AD. So we know we at least have a parallelogram. We also learned that AB is not perpendicular to AD because they're not opposite reciprocals. So AB is not perpendicular to AD because they're not opposite reciprocals. So there's no right angles in the corners, so that means we didn't make it a rectangle or a square. But now when we look at the diagonals are opposite reciprocals. So they are perpendicular. So that means you do get right angles by the diagonals. So it's a parallelogram with the diagonals being perpendicular. So it ends up being a rhombus. That's what you're going to have to do, and you're going to have to take it apart and be able to answer those questions. They will do it. It's a challenging question, but they're able to do it. And last but not least, number 8, you have a parallelogram. That's what this symbol is telling you. You know that YP is perpendicular to WT. We also know these are perpendicular, causing a right angle here. So we got a bunch of right angles. We also know that TP, this little piece here, is going to go into TZ, this little piece here. And what else do we notice? We got a shared angle here that's reflexive. So we're going to be able to prove this triangle is congruent to that triangle by angle side angle. All right. Well, first off, we had YP was perpendicular to TW, giving you angle YPT is a right angle. We're also given that WZW is perpendicular to TY, giving you a right angle at WZT. And these together, we're able to prove that angle YPT is congruent to angle WZT. We also knew that the side was that TP was congruent to TZ. And then we learned from the diagram, reason 3, angle T is congruent to angle T because it's reflexive. We're able to get up to reason 4, the triangles ZTW is congruent to triangle PTY, which then we're able to say that TY is congruent to TW, which if this side is congruent to this side, and we know it's a parallelogram, and we got YTWX is a parallelogram. Now we can finish it up, and we can say that it ends up being a rhombus, because if it's a parallelogram with consecutive sides being congruent, it ends up being a rhombus. And now let's give our reasons, and we're done. So reason 1, definition of perpendicular. Reason 2, all right angles congruent. Reason 3, reflexive. 4, we had the angle side angle, which makes 5, the CPCTC. 6 is just definition of rhombus. So, thank you for watching this lesson. Have a good evening, and we'll see you later.